Welcome back to WICKERSON Studios, the Geometry to the Point and Beyond series of Ghpython WICKERSON Studios nodes. We're going to try and get to a half-decent script and fly through this section here. Lots of examples have come in. I'll be offering this in a to the point and beyond repository on my GitHub to people if they want this master file called WICKERSON Studio Master to the Point 002, and it also will include these red to the point test nodes if they're in use. So those user objects are in that GitHub file as well if you want to get in here and have some fun. Remember, the base scripts are here. They're pretty dry and boring. They're coming out of the text that I'm getting sample files from, but I'm trying to apply them to some interesting examples down here. And this is really the genuine things that I'm developing that you may find interesting from WICKERSON Studios. So let's jump in here and leave all this other stuff. We're not going to need it. We're going to fly through some pretty fast things. So let's jump into the example files, and we're thinking curves now. We're thinking lines, we're thinking curves. So what do you initially have to do to get a line out here? And this is still RhinoScript syntax stuff. This will be extremely primary and basic right now. So let's just fly through it pretty quick. If you want to, and like they always say, find the nodes that you might want to copy. So one of the ones that I always use all the time is over here in sets, and it's this line node. So really, that just takes a start point and an end point and produces a line. So you should be able to script something like that in RhinoScript syntax using that RhinoScript syntax. Even if you want to try some Rhino Common, that would be fine. Rhino Geometry. So after that, you basically are creating a line. It's as simple as that. And you go to RS, and you want to do something. So you're adding something. Well, what if we start to type add line? Well, there's one that completes. And what does it want? Down here at the bottom, it says it needs a start and an end point. And it has an example right here. Now it of course goes into an example that we don't use. I don't use the get points. I don't use the get things in this node because I can always set things in place. So what I'll probably do is zoom in here. Say this is 0.1, and this will be 0.2, and this is not very exciting. It's pretty simple. But 0.2, just so you remember what's going on. Of course, type int has to be set to 3D. Let's call it 0.3 double. Instead of 0.3D, which kind of confuses what things are going on. You're getting an XYZ number or attributes to drive those points, and you could always make it interesting, which is kind of silly to go in here and say, okay, let's construct a point, which is basically what we're doing, but let's construct a point, and let's construct a second point. And that way we're not dependent on the 3DM file or for internalizing or putting things into containers. I like to avoid all these containers as much as possible. That way my Canvas scripts run without having to tag them to a 3DM file. So let's just grab a couple of, we'll just use a couple of variables, floats between here and here. It really doesn't matter what we input. We can input those, but what's nice is we could just mix those up a little bit and then put them in a different order down here. Of course, we'll end up getting different points by doing that. So those 2 points have been inputted. We will have to output definitely, what should we call it? Let's just call it, well, what it is. It'll be a line out, and that will come out of this script. And when we have that line, we're definitely going to want 0.1 as an attribute, and we're going to want 0.2 as the second attribute because that's what it needs to make a line. And then we simply have to set our output to line underscore out equals line, and that should run fine if I haven't messed up anything. And that should bring us to not only our params, no fault with our scripts, and we're getting a line-like curve. And if you want to, you can throw it into a curve node for visualization down here. Hit OK, and there you go. You have your exciting little line that's behaving the way you are driving things in your grasshoppers. So whoop-de-doo, you can have fun with that. So pretty basic stuff, and it should be easy enough to kind of decipher what you've done. And if you want to do the same thing and just grab those points into here, you'd have the same kind of jazz happening. And there it would be working through that node. But of course, if you double click on here, you get nothing. And if you hit help, it'll tell you exactly what you have to do. But in this one, you can go in and you can get into your script and you can start doing some magic and feeling like you're a little more of a computational designer in your work. So pretty simple stuff. We'll just keep plugging away. Let's disable that one, and let's go in and grab another node, and we'll try a couple in this series, just dealing with lines and curves. Let's focus in on there, and we'll try to do something that involves a little bit different things besides just add line. So let's jump in here. Let's bring this back down. I'm going to use 3 different types, and we'll see the application of these as we get going a little deeper into it. We'll use RhinoScript syntax, roll up our sleeves, get to work, and we are going to create curve A, and we are going to set that to RhinoScript. And this is just like using the math library, just like using random, figure out what all these things mean. But since we kind of know what we want, and we're adding this time a polyline, that should come up. It will tell us down here exactly what we need. We need points. We need to replace ID, and that's set to none. So you literally, since it's set to none, you can just type in the points that you need. And the points are going to be our data or inputs that we're bringing in here. So let's cut the Y, go over here and say these will be our points. And you'll find a way to generate points just like I did with number sliders and other nodes. We'll set that type hint 3D 0.3 doubles, and I probably will just grab something interesting over here as a 3D geometry, and I'll try and make those points on a more reasonable count. Let's say 12, so we don't have to get so crazy for this line, and we can also seed it to that as well. And so as we change it, run the script again and again. And it's coming in as a list, and I believe because it's coming in as a series of points, you're going to have to also type your list access away from item access. And that should keep this running. With any luck, we'll be able to use our panels, and we'll keep an eye on a panel for now, and we'll get down to scripting a little more into the script. Curve A is this one. Let's do a curve B, which is going to be equal to a RhinoScript at add curve. And that's going to ask us for points in a degree 3. So we don't even I don't even think you have to type that in degree curve. I can just put in points and see what that's going to end up being. But since we have a chance to do different degrees, I'm going to just type in degree and and see if I can't just go in here and give myself a little tiny. Well, first of all, I'm going to add myself the name, and I'm going to send that degree to an integer. I'm not sure if this is going to work, but like most things I test, I'll double click. I'll hit, we want 1 degree to 5 degree, and let's set it over at 3 so we know what at least to run at that one because that's what it wanted. And let's see if that curve with an output will do curve A out is equal to curve A. Oh, we don't have to write all that. That's what you have to do when you set it. And we'll add one here, and we'll say this one is curve B underscore out. And we will make sure that we have curve A underscore out equaling curve A, and we will have curve B underscore out equaling curve B. And let's try and run that and see if we're not having any trouble. Looks like we're doing okay. Let's grab a little curve. We'll have 2 that we can pick at, otherwise we're just grabbing the node and we're seeing everything. And what I'd like to do is see that this one's running. Let me hit OK for now. There's our little curve. That's jostling and dancing whenever we want to move that and get more or less points within that space. And we can take this tool and put that to preview off, so we're only looking at that curve. And sometimes it's nice to go to a standard and just only be seeing what you want to see. Oh, that was weird. Oh, it's because it's maybe because it's not in Rhino, but I think I should be able to just be getting that. Anyway, that curve's there, and this curve is here, and that's a degree 3. So let's pull that back to degree 1. So it looks like that one, 2, 3, 4, 5. So we actually have a chance to put in whatever degree we want, and I like that 3 curve. So that's just adding a little bit into the script. Let's open it back up and continue. Our next curve, C, we will set equal to RhinoScript at add interp, and I actually want interp curve, and that will ask me for a degree points, degree 3, not style, a start, a tangent none, and an end tangent none. So you have a lot of chance to add a lot of things, but simplicity's sake on this currently, we'll just jump right in. We're not even going to worry about the degree and set that the points. And then we can just, with a control copy and paste, and go in here and change B to cap C and cap B to cap C. And we can go in here and grab our curves C underscore out, and that should allow us one more curve to play with and see what we have. So pretty simple scripts to start. We're really just getting the basics of what's going on. Our script should run, and I believe everything's fine. We've got this curve. Oh, it really is like angry at me for some reason. Why? Oh, it's that big curve that I've got in there. Let me take that and visibility, send that one off. And let's take that nasty curve. I don't even know where I have that one working. Why did I even play with it? It's way over here in this geometry. Let's take disable. Now I should be able to avoid that massive thing. No, it's just as ugly as it was before, and my my object is not wanting to zoom in on itself. Come on. Well, very strange. I must have something. I just have too much going on in the script that's just angry with me. So let's take a look in here. That's very strange. I don't want a one-to-one factor. Well, let's take a look at that shape. It's poly 1, that one is 2, and that one is 3. And if I had any luck, I'd be able to zoom in here. So, that's strange. I guess I just have too much going on all my sample files, and it's time to start another one. Disable. Let's take all this. Disable. Let's go into here. That's disable. Yeah, I'm just having a little trouble with my... There, that should pick it up. Okay, well, it's still tiny. I guess what I could do is take my region tool and make a massive region, which is set right now to a box. And what I like to do sometimes, I'll just show this. When it sets you to things, extract what you have and grab your data on that box. And that's always kind of fun to think about. And then you can end up checking out the scale of that. But since we're creating that box, and I'm having trouble with this little nasty guy, let's go into a solid. Let's create a center box, and let's jazz it up to the size we want. So at this point, if it's not going to behave this size, and I'm going to have trouble with my viewport because of all my files, let's go in here to this box, and there it is. Now it's behaving the way it should. And I should be able to go back in, take a look at that object, and that object. You can see the difference between each one of them as it's going. I'm still going to attempt this. Yeah, there it is. And of course, we can get rid of that box to visualize. Sorry for that little change, but you can see with those huge numbers, I obviously don't need 10 points to make all that. Let's just choose, let's just go in here and edit this down from 100 to 10 and bring that down to 4 count. There we go. We have a nice line there. We can color them differently. There's the poly line that's coming out because that was written as the script over here as add polyline. That's the add polyline. That's the add curve with the different degrees that I can play off of. Because I made that, at least I thought I did. Yeah, there's 1, 2, 3, 4, 5. So that's working. And then there's our add interpolated curves. So they're all different curves and they work fine. That's pretty much textbook exercises, but it did get us thinking a little differently if you looked at it. We actually had to go into these points and get a proper list access because we were starting to take more than one. And we wanted to process this in one run. Okay. So that was another thing. I didn't think it was going to take that long, but it certainly did. Another little sample out of the text to get you thinking of scripting. And we are on our way to try and bring this up to doing points closed and inside of a curve and outside of a curve. But one other script I wanted to try and squeeze into this video, if you're interested. We'll just keep going. We'll jump in here and we're going to grab the script editor, pare it down to, I believe we're going to import another library. This one, we're going to import not just RhinoScript syntaxes RS, we're also going to import random. And I think we'll just bring it in as random. We don't have to make it as R. I just have to make sure it says random, not rammed. We will create a point list, empty, and we will do an iteration of 4 I in range. And we'll just set it from 0 to, we can hard code this in at 100 for this one. Then x will be equal to, and we're using the random function, uniform, which will give us a decimal between whatever numbers we set. We can set 0 to 100. We can cut and paste that with a quick copy and then a paste. and another paste. And of course, we're going to want to go in a Y direction, same uniform, and a Z direction. So we get a nice box. We will take those point. We will create a point, and then we will use the Rhino script to add a point to at the XYZ, and this is the base code, which we've done a few times before. And we will append the points list. We will append with those points. And in doing so with those points, but the title is point, we'll have to leave the scope of the function, and we will create a curve that's equal to the Rhino script function add curve at those appended that appended list. Something just went wrong. At that appended list of points, and we will output the curve list out equal to curve without an O. Curve. And now all we have to do is go in here and take our curve out, and that with any luck will run. Something went wrong in 13. Add curve is not an attribute. Rhino script add curve. Give me a capital A. And that was the difference. I wasn't running the function as that. Now, once you get a script up and running and you know you have a curve that's coming out, and you can take a look in your params and visualize that, and you have nothing going wrong with your script, and there it is, this monstrosity, because it's a big jumbly mess made up of 100 points. We definitely want to bring this down in the XYZ, and since this is hard-coded, we're just going to call this, we're just going to change that hard script to num_x, and we'll change this one to num_y, and this one we will change to num_z. And this is when you start playing and becoming a little creative in your own right. Go into here, add. You're going to want to add num_x as an integer. You will want to add y, num_y as an integer. And now we can get a little more control of what we were doing within this, and a num_z as an integer. Not a very fancy script, pretty basic to say the least. Let's bring the count down to 12 in all directions and play with that on pasting twice and copy and pasting, and see if we can't just start to push this in one way or the other. The count in y is down, num_z, num_y, but our real count is we're getting such a random number within there, we're probably going to want to bring this down to a count of, let's bring it down to 12. Let's bring it down to a count that's much lower. And let's just plug that in there and bring this count. Just picking a variable name because I feel like it. And take the type int down to integer. Pretty basic stuff. 12 to begin with. It's just common practice. And then we have this way of going in and finding the ranges of all these numbers. Let me test it. And we have a much simpler point form. If we bring that down to 12 or even 6 for that, let's say 6 points within that box. And then the size of that box has been adjusted by here so it's not so massive. So I could make the box huge again, but it still makes a very reasonable. And I really have trouble with that point. I've never found a way of getting rid of that point yet, but you can see you can have some really nice variants on that. And of course you can also bring in, because you're using random, and I always like to do this before lists, random dot seed as, and then here's the example where I use kind of my own style of seed. Add that. That's where we use caps, so we're distinguishing between the function name, type hint, integer, and then we're able to throw in whatever we want. That's just a finger habit of doing that. But now you have a seed that can change those very quickly without having to change the count and run the script again. But pretty simple stuff to start, and that's just creating a curve by random points and having fun with that. And of course, we've done that before. I think I actually did that on the 2D model instead of the 3D model. But interesting that we wrote this without having to do points to pick points from in like 2 nested iterations in XYZ direction. We did it in a uniform kind of way using the random uniform tool and whatever size we wanted to set on our box. So it's not so I didn't have to get into more nodes. I could actually run that as just number sliders into that script. So I've been getting into the habit of saying to the point, underscore random points. I probably should have done that. And I think we should go back and say what the other one was back up here, which was a node for to the points, and that was creating poly, curve, and enter. I think I did that before, but we'll just call that one. In case then I don't think we named our first function, which was just to the point and beyond, which was line curve. So that they've all got names. And anytime you make something that you really like if you like this little cluster, if you like this kind of random curve tool that you can change the size and shapes from number sliders, let's just get into the practice and do this again as a test. Go into your file, hit your create user objects, grab your random points, throw it in here, test, grab the icon over here, throw it into that wary red, and test should be fine, and there it is. We should have another one that pops up, and who knows where it comes out. Array of points. Oh, probably it'd be the last one I pick. Random point. No, it was the last one I picked. Random points. So there it is. Bring it in here. You have the original script, but you can also go in here and plug in all these wonderful juicy numbers. You have your own little user object that you can share with people, and the bonus of that, which I'm finding working in C# and working in Python and doing this, is that people don't have to have the same plugins as you. You can send them your user object on files to run the scripts that you want, which really makes them kind of not so much dependent on you, but definitely valuing your time, what you're scripting for them. Pretty easy script. Just took the, I don't know who can own that conceptually, but when you start to really play with it and change it up, it becomes a useful little tool for somebody. Thanks again for watching. WICKERSON Studios.